1111 goes over solving equations by factoring. When we solve these equations by factoring, you want to go through every single type of factoring there is. Can you factor out a greatest common factor? Can you factor when a is 1? Can you factor by multiplying your a and your c term? Do you have a perfect square trinomial? Do you have a difference of squares? Do you have 4 terms to where you can factor by grouping? So again, you want to keep that in mind throughout every process of these equations. If we look at the first set of examples, these are factored for us. So the only thing we have to do once our equation is factored completely is to set each part equal to 0. So if we look at example 1, we have x plus 2 times x minus 5 is equal to 0. Each part is going to be set equal to 0, and you're going to solve for both. So we're going to have x plus 2 is equal to 0, and x minus 5 is equal to 0. Now you just solve for both of these. For the x plus 2 is equal to 0, subtract the 2 from each side, and we get that x is equal to negative 2. For the x minus 5 is equal to 0, add your 5 to each side, and you get that x is equal to 5. For example 2, we have 5n times n minus 3 times n minus 4 is equal to 0. So again, this one is factored for us, so we just set each part equal to 0, so we're going to have that 5n is equal to 0, the n minus 3 is equal to 0, and the n minus 4 is equal to 0. For the 5n is equal to 0, we're going to divide each side by 5. 0 divided by anything is 0. For the n minus 3 is equal to 0, we're going to add the 3 to both sides, and we get that n is equal to 3. For the n minus 4 is equal to 0, we're going to add the 4 to both sides, and we get that n is equal to 4 as well. For this one, we have 3 solutions, 0, 3, and 4. For the next set of examples that we're going to be looking at, for example 3, we have 2x squared plus 5x is equal to 12. So that's another thing that you want to look to at is to see if your equation is equal to 0. If it's not equal to 0, move your constant or whatever term is by itself over, so that way your equation is equal to 0. So for this one, that's what we're going to start with, is to move the 12 over by subtracting it from each side. This is going to give us 2x squared plus 5x minus 12 is equal to 0. Now that our equation is equal to 0, can you factor out a greatest common factor from these 3 terms? The answer to that is no. Your a term is something other than 1. So multiply your a and your c. A is 2, c is negative 12. 2 times negative 12 is negative 24. Find the factors of negative 24 that add up to be 5. If you don't know them off the top of your head, start with 1 and 24. You then have 2 and 12, 3 and 8, 4 and 6. If the 3 is negative and the 8 is positive, it gives you a positive 5. So we're going to use a negative 3 and an 8, add an x to both of those, and you're going to have 2x squared minus 3x plus 8x minus 12 is equal to 0. Now that this is expanded to be a 4-term polynomial, factor by grouping. Put parentheses around the first 2, put parentheses around the last 2. You can factor out an x from the first set of parentheses. You can factor out a 4 from the second. So this is going to leave us with x times 2x minus 3 plus 4 times 2x minus 3 is equal to 0. This gives us x plus 4 times 2x minus 3 is equal to 0. From here, set each part equal to 0 and solve for both of them. You're going to have x plus 4 is equal to 0, and you're going to have 2x minus 3 is equal to 0. Move the 4 over by subtracting it from each side. You get that x is equal to negative 4. For the 2x minus 3 is equal to 0, add your 3 to both sides. Then divide each side by the 2 to get x by itself. And you have that x is equal to 3 halves. So, the negative 4 and the 3 halves are your two solutions for this one. For example 4, we're solving this cubic equation. We have 18y cubed plus 8y plus 24y squared is equal to 0. For this one, the first thing I would do is to write it in standard form, which means I would have my highest exponent first, my lowest last. My first thing that I do see is that my equation is equal to 0, so I don't need to move anything over to the other side of that equal sign. If I do write this in standard form, though, we're going to have 18y cubed plus 24y squared plus 8y is equal to 0. I do have a greatest common factor that I can factor out from these three terms. It is 2y. So we'll factor out a 2y. This leaves us with 6y squared plus 12y plus 4 is equal to 0. Now with this, it is. I don't know why I put the 6 there. I think I was thinking about dividing by 3. I'm sorry. So this 9y squared plus 12y squared, or 12y plus 4. Now that we have that 2y factored out, we have a trinomial where we have a y squared that comes first. You can do this one of two ways. If you realize that you can take the square root of that 9y squared, you can take the square root of that 4, you get 3y and 2. The sign on that middle term is positive, so if you take 2 times 3y times 2, it gives you the 12y, which is that middle term. So this is a perfect square trinomial. You would just have the 3y plus 2 squared in order to factor it. Do you have to use that method? No. If you didn't want to use that method and you wanted to multiply the 9 by the 4, you get 36. You find the factors of 36 that add up to be 12. You can factor it that way as well. Now with this, you have that 2y that you're going to set equal to 0. You also have the 3y plus 2 squared is equal to 0. You could have separated that 3y plus 2 squared to be 3y plus 2 times 3y plus 2. However, when you solve it, you're going to be doing the same exact thing for both equations, so you don't necessarily need to do it twice. For the 2y is equal to 0, we can divide each side by the 2, and we get that y is 0. For the 3y plus 2 squared is equal to 0, we can take the square root of both sides. We're going to have 3y plus 2 is equal to 0. We're going to subtract that 2 from each side. That gives us 3y is equal to negative 2. And then we're going to divide each side by the 3. And we get that y is equal to negative 2/3. So we have two solutions here, the 0 and the negative 2/3. Your next set of examples, for example 5a, we have 4x squared plus 12x plus 9 is equal to 0. So if you remember from the last question that we just went over, we had a perfect square trinomial because when we take the square root of the first term and the last term, we got the 2x, we get the 3. If we keep the sign of that middle term and use it with a 2 times those two terms, we're going to get that middle term, which is the 12x. So because that 2 times 2x times 3 is that 12x, and it is the same as that middle term, we can just take the 2x, the sign in the middle is positive, plus 3, and square it, set it equal to 0. From here, we can do the same thing that we did for the question before this. Take the square root of both sides. It cancels out the power and the radical. So we have 2x plus 3 is equal to 0. Subtract the 3 from each side. Divide each side by the 2. And you get that x is equal to negative 3 halves. If we look at example B, we have 25x squared minus 1 is equal to 0. For this one, we're going to add that 1 to both sides. And we have 25x squared is equal to 1. From there, we can divide each side by the 25. So we just have x squared is equal to 1 over 25. We're going to take the square root of both sides. Remember, when you're taking the square root of both sides, you put that plus or minus in front of your answer. And we have x is equal to plus or minus 1/5. For example C, we have 25x squared minus 10x plus 1 is equal to 0. For this one, we do have a perfect square trinomial, so if you take the square root of the 25x squared and the square root of that 1, we get 5x and 1. The sign on that middle term is negative, so that would be a negative 2 times 5x times 1, which gives us the negative 10x. They are the same term, so this factors out to be 5x minus 1 squared is equal to 0. So another way to do this is you can take the 5x minus 1, set it equal to 0, or here, let's do it this way. 5x minus 1 times 5x minus 1 is equal to 0. You can set both parts equal to 0, so 5x minus 1 is equal to 0, 5x minus 1 is equal to 0, and then solve for both of them. This is what I was saying, that if you did it for both of these, you're going to get the same exact answer. So you're just repeating what you're doing. So you still have that x is equal to 1/5 for both. And you only need to give that x is equal to 1/5 one time for your answer. For our last example, D, we have 8x to the 4th power minus 2x squared is equal to 0. For this one, we can factor out a greatest common factor first, which is just the 2x squared. So this is going to give us 2x squared times 4x squared minus 1 is equal to 0. Now with this one, you do have a difference of squares there, so if you wanted to, instead of setting each part here equal to 0, you can do the 2x squared times 2x minus 1 times 2x plus 1 is equal to 0, and then set each part equal to 0. So this would give us 2x squared is equal to 0, 2x minus 1 is equal to 0, and 2x plus 1 is equal to 0. For the 2x squared is equal to 0, divide each side by the 2. You get x squared is equal to 0. Then you take the square root of both sides, and you get that x is equal to 0. Remember, 0 is neither positive nor negative, which is why we do not put that plus or minus in front of it. For the 2x minus 1 is equal to 0, we're going to add the 1 to each side to start. We have 2x is equal to 1. Then we divide each side by the 2, and x is equal to 1/2. For the 2x plus 1 is equal to 0, we're going to subtract 1 from each side. We have 2x is equal to negative 1. Then we divide each side by the 2. And we get that x is equal to negative 1/2. So again, you have 3 solutions here: 0, 1/2, and negative 1/2. If you wanted to write it as 0 and plus or minus 1/2, it is the same thing. You can do that as well.